Training an AI to be a real deep research assistant, that's one of the biggest mountains to climb in the field right now. But what if we've been making it way harder on ourselves? A recent paper from Tongi Lab suggests that we might be literally throwing away our best training tool. So let's dive into how they're turning what looks like digital trash into some serious AI treasure.
I mean, really think about that for a second. What if, in the very process of trying to teach these advanced AIs, we're actually creating this incredibly rich, valuable resource, and then just tossing it out like it's nothing? Well, this explainer is all about a fascinating new way of looking at the problem and how a team of researchers found a hidden gem right in the data we've all been ignoring.
Okay, so to teach an AI how to solve really tough problems, you need, well, a ton of tough problems for it to practice on. The thing is, you can't always just find these out in the wild, so researchers have to get creative and make their own. And this is where a super important concept comes into play: synthetic data. It is the absolute foundation of this entire process.
Synthetic data is pretty much exactly what it sounds like. It's data that's been artificially cooked up just for training AI. For this kind of research, it means building these really complex, tricky questions out of simpler ones. And along the way, they embed these key little facts into the question. These facts are called entities, and you can think of them like breadcrumbs the AI needs to find and follow to solve the whole puzzle.
And this is how they do it. It's actually pretty clever. You start with something anyone can answer, right? Who directed Titanic? Simple. Then, step 2, you inject one of those entities we just talked about. Instead of Titanic, now it's the 1997 film starring Leonardo. Then, step 3, you hide it even more. You replace Leonardo with another fact, another entity, the actor who won the Oscar for The Revenant. All of a sudden, you've got this multi-step reasoning problem, and its very DNA is made of these little facts, these entities that the AI has to uncover one by one.
All right, so we've got our synthetic questions, and they're packed with these super useful entities. Now, the standard way to train an AI on them is a method called Group Relative Policy Optimization, or GRPO for short. But it has one really big, glaring flaw. The paper itself puts it perfectly. GRPO uses sparse, outcome-based rewards. What does that mean in plain English? It means it only cares about the final answer. It's like a teacher grading a really hard math test who just marks it either 100% correct or 0% wrong, no partial credit. It completely ignores all the brilliant work the student might have done along the way. And this right here just illustrates the whole problem so well. On the left, you've got a complete failure. The AI is totally off base, it's not even close. But look at the right. This is what we call a near miss. In this case, the AI actually did some amazing detective work. It figured out the actor was Leonardo DiCaprio, but then it just stumbled on the very last step and got the final director wrong. It showed fantastic reasoning, and that's incredibly valuable information. But here's the kicker. With that old GRPO method, both of these attempts get the exact same grade, a big fat 0. The one that was completely lost, no reward. And the one that was so close, the one that showed all that promise, also no reward. All that valuable, almost correct thinking just gets tossed in the digital trash bin. So what's the consequence of all this? By treating every single wrong answer as the same kind of failure, you're forcing the AI to relearn things it actually got right the first time. We're just completely discarding these rich, powerful learning signals that are buried inside those near misses. This is where the researchers had their big aha moment. They started to think, wait a minute, maybe there's a hidden signal in all that data we're throwing away. And they looked right at the source, the entities from the synthetic data they created. And when they analyzed the data, they found something pretty remarkable. This chart tells the whole story. There is a super strong positive link here. When the AI got the final answer right, it had a really high entity match rate, meaning it found most of those key facts, those breadcrumbs. But when it got the answer wrong, that rate was way, way lower. It turns out the number of entities the AI found was an amazing predictor of success. The answer was right there the whole time, just hiding in plain sight. The key to a smarter AI wasn't some brand new, crazy complex algorithm. It was simply about repurposing the digital waste, those very entities inside the questions that everyone had been ignoring. So armed with this huge insight, they built a totally new framework. This one doesn't disgrade the final answer. Nope. It actually rewards the AI for taking the right steps along the way. They call it E-GRPO. The E stands for entity aware.
The idea is so simple, but it's incredibly powerful. Instead of just pass or fail, the AI gets a reward that's proportional to the number of correct entities it finds. It finally gets credit for doing good work, even if it doesn't get a perfect score.
So let's go back to our grading example, but now with the new E-GRPO method. The complete failure still gets a 0, as it should. But the near miss, now it gets partial credit. Because it found some of the entities, it gets a small reward. This is a game changer. It basically tells the model, hey, you were on the right track. Keep doing that part, just fix the ending. It's a much, much smarter way to learn. So, the million-dollar question, does this new, smarter grading system actually lead to a smarter, better AI? Well, the results really do speak for themselves. Just look at this data. It's pretty compelling. Whether the AI was training in a closed local system or out on the open web, the model trained with E-GRPO consistently scored higher than both the original base model and the old GRPO model. We're talking a significant, consistent jump in accuracy across the board. And get this, it's not just more accurate, it's actually more efficient too. The agents trained with E-GRPO figured out how to solve problems more directly. On average, they needed about 10% fewer steps to get to the answer. So not only is it getting the right answer more often, it's getting there faster. That's a huge win-win. So if we boil this all down, what are the big takeaways? First, those near misses are absolute gold mines of information. Second, the data we so often just throw away can have these hidden signals that are key to better learning. And finally, when you reward the process of thinking, not just the final outcome, you build AI agents that are demonstrably more accurate and way more efficient. And really, this points to a much, much bigger idea, doesn't it? It makes you wonder, what other kinds of digital exhaust, all the data we create and then just discard without a second thought? What else are we ignoring? What other hidden gems are just lying there in plain sight, waiting for someone to repurpose them for the next massive breakthrough in AI?